Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 547, number of provinces. This is a medium level graph problem, and we're told that we're given n cities. Some of them are connected while some are not. And if city A is connected directly with city B, and city B is connected directly with city C, then city A is connected indirectly with city C. So the A, B, and C will be a province. And we're told that we're given an n by n matrix is connected, where it's connected to ij equals 1 if the ith city and the jth city are directly connected. So we're basically given, and we need to return the total number of provinces. So we're given, so for each, this is basically like an advanced version of what is an adjacency list. So for each node, we will have whether or not that node is connected to those nodes. Okay, so what does this even mean? So let's say we have two nodes, 1, 2, and 3, or we have 1 and 2. Is this two connections? No, yes it is. So this part is a connection on its own, and this is a connection on its own. If we had, for example, a 6 over here, that would be a connection. A 4 and a 5 and a 7, what would these be? Would these be three connections? No, they would also be considered a single connection or a single province. So we would have 4 provinces in total. And remember, each node is a province on its own. So in this example below, we've got 3 provinces technically. Okay, so let's actually hop into how we're going to code this problem. The first thing we want to do is say, let's actually create a normalized adjacency list that we would be able to work with. So let me comment this actually. Let me just say build adjacency list, and we want to say for let I equals 0, I is less than is connected dot length I plus plus, and then do the same for all the values within each connected to each node. So j equals 0 is connected 0 dot length, or is connected to I dot length, and j is less than this, j plus plus. Okay, so now let's actually get the value. So get the value is connected ij, so this is the value of the current node that we're at, and if that value, like we're told above here, is equal to 1, well, we know that the ith city and the jth city are basically directly connected. So we can say if adjacency I, if not adjacency I, then we want to say adjacency I equals j. Otherwise, we can push to our existing list, existing I dot push j. Okay, j. Okay, so that is our adjacency list built. So this is just a normalized adjacency list as with any other graph problem. Now we need to do depth first search and actually check. For each depth first search, we want to mark off visited cities so we don't add them again, and basically count the number of provinces we have. So let's say visited is going to be equal to a new set, and count is going to be what we return. That's going to be equal to 0. Okay, so we're going to iterate through basically each key in our adjacency list. So we're going to say each key in our adjacency list, and remember that JavaScript, the properties of an object are going to be strings, so we need to pass them. So we're going to say pass int key. This is going to give us a key as an integer, and we can pass it to our depth first search function. Then let's get to actually writing our depth first search function. So we want to take in a node, and that's about it. We don't want to return anything. Actually, we do want to return. We want to return the count. If visited dot has node, well, we've seen this node before, so we just return 0. We don't need to return anything, and we don't want to increment our count because it's already part of a province. Otherwise, we're going to say visited.add node. Honestly, guys, like if you're writing this yourself and you want to change visited to is already in province, and if that makes more sense to you, then go for it. I think naming your like semantic naming or naming your variables, that makes more sense to you. I'd go for it because it does make understanding the problem a lot easier. But just for this example, we're going to stick to visited, and then we want to get all the neighbors. So all the neighbors is going to be equal to JSON node. We want to iterate through all our neighbors. So for let n of neighbors, we want to do a depth first search on each of these neighbor nodes, and then we want to return 1 once we're finished. So this will count our provinces, and then we can just return our count. So that looks good to me. Let's run our sample test cases, and we get an issue if not a JSON CI. JSON C is not defined because we have not defined a JSON C. So let's define a JSON C real quick as a JavaScript object. Let's check again. And we pass our sample test cases. Let's check our code does pass all test cases and our submission is accepted. And we have an optimal solution as well, guys. So in terms of time complexity, we're looking at an O of n squared, so a quadratic time complexity, and space complexity is going to be big O of n. And with that being said, guys, I hope you enjoyed this video, and I will catch you very soon.